This is me, Pratik, and today we will be solving Leetcode Biweekly contest 147. So let's get started. In this problem, we are given a string S and we are given a pattern string P, where P contains exactly one asterisk character. The asterisk in P can be replaced with any sequence of 0 or more characters, and we have to return true if P can be made a substring of S and false otherwise. So what is a substring? Substring is a contiguous non-empty sequence of characters within a string. Okay. So let's look into the example. So in this we have given a string S as lead code and P as E asterisk E. So here P E is matching with this E and this E is matching with this, and these are the T C O D is matching with the asterisk. Okay. So from that what you can observe is, like, if we are having a asterisk in the starting, that means we just have to check the remaining character in the string, because all other characters can be replaced. Okay. Or if we are having a asterisk in the end, then also we just have to check the remaining thing in the string. If it exists, then we can return true. But the only case we have to check is when the asterisk is in between of that. Okay, so when the asterisk is in between, then we have to check the left part, which is EE, in the string. So whenever we get the part EE, then we just have to find out the right part in the remaining string. So we remained with T code, and we have to find out the E. Whenever we get the E in this remaining string, then we can return true. Okay. So let's look into the code. So first we have taken the length of string, we have taken the length of pattern. After that we are checking that if the asterisk is in the starting position, then we can just check the characters from the first position in the string. If the asterisk in the last position, then we can just check the remaining character in the s. So whenever the asterisk is in the middle, we are having a left part, we are having a next part. So we will check the left part in the string. So whenever it is matched, then we will be checking the next part in the remaining string. If it is matched, then we are returning true. If it doesn't match, then we can just return the false. Okay, so that's it for this program. So in this program there is a task management system that allows user to manage their task, each associated with a priority. The system should efficiently handle adding, modifying, executing, and removing tasks. So we have given a task manager class. On that we have given a tasks. So what task of I is indicating? So in a particular task we are having a user ID, we are having a task ID, we are having a priority. Okay. So what is add method doing? Add method is giving us a user ID, task ID, and priority. So we have to add that. And edit means we have to edit the task with the new priority. And remove means we have to remove the particular task. And execute top means we have to execute the most priority task and we have to remove it. Okay. So how we can solve it? There are many ways to solve it. We can use a priority queue or some other data structure, but we can also use the sorted list from the sorted containers to solve it. So I will be showing you how we can solve it using the sorted list. Okay. So what we can do is we can take a sorted list and we can take a tasks. Okay. So in the sorted list, we will be adding the priority, tasks, and user ID. So in sorted list, that every element will be in the sorted manner. Okay, in the increasing order. So all of them will be sorted according to the priority. If the priority is same, it will be sorted according to the task ID. If the task ID is same, it will be sorted according to the user ID. Okay, and task will be containing the task ID and priority. So every task ID is having a some priority. Okay, so we are having a add method that is adding the priority in the task and adding it into the sorted list. After that we are having a edit method. In this we are taking the priority, we are getting the task. How we can get the task? We can do a binary search, okay, in the sorted list. That will be giving us the task in log of n time. Okay, after that we can just remove the task from the list and we can add the task with a new priority in the sorted containers. Okay. After that, we will do similar thing in the remove function as well. First, we will find the priority. After that, we will be just doing a binary search to get the index, and we can use a pop operation to pop the element from the sorted list. Okay. So for the execute top function, we can just check if we are having a sorted list. If we are having that, then we just return the user by popping the element. Otherwise, we can just return the -1. Okay. So we can solve this question very easily using the sorted list by the sorted containers. If you have any doubt in the sorted container or any issue with the code, please let me know in the comment section. I will try to resolve it. In this problem, we have given an array of integers nums, and our task is to find the longest subsequent sequence of nums such that the absolute difference between consecutive elements form a non-increasing sequence of integers. So in other words, for a sequence like a sequence of 0, sequence of 1, sequence of 2, to till sequence of m of nums, so the difference between sequence of 1 minus sequence of 0 should be greater than or equals to the difference between the sequence 2 and sequence 1, and so on. And we have to return the length of such a subsequence. So what is a subsequence? A subsequence is an non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay. So if we just look into the first example, so nums is given as 16, 6 and 3. So if we have taken the 16, 6 and 3, then absolute difference between these elements are 16 and 6 is 10 and 6 and 3 is 3. So it is in non-increasing order. So we have to find out the length of longest subsequence. Okay. So how we can solve it? So if you just observe the question, you will try all possible ways. So you will try to get the answer by all possible ways, and you will try to optimize it using DP. And you will get some kind of transition states like this. In this, we have taken the index, the previous num, and the differences. But if we just look into the constraint, so the nums of length is 10 to the power 4, and nums of I is lesser than or equals to 300. Okay. So if we just compute the time complexity for this, it was about 10 to the power 4 into 300 into 300. That is about to giving TLE. So how we can optimize it? So if we just look, we don't need the previous num. Okay. So what we can do is we can use some kind of these things. In this, we have taken the index and difference as the states, and for the transition, we are going all the indexes and try to find the absolute difference. And if the absolute difference is smaller than or equals to differences, then we are just finding the answer. But here also, if you just compute the time complexity, it is n into differences. That is n square into m, where m is the maximum number of element. So that is also giving us a TLE. So how we can optimize it? So here, if we just look, we are going to all the indexes. But do we need all the indexes? So we need indexes whose difference is lesser than or equals to difference. Okay, so what we can do is we will be using a delta in the range of difference to 0, and we will be doing the computation for next positive index and next negative index. We will be writing some logic to get that in big of 1. Okay, and we will be using delta, and delta will goes up to difference only. So the time complexity for this is n into m into m. That is also giving us a TLE, because 10 to the power 4 into 3 into 10 to the power 2, 3 into 10 to the power 4, which is about 10 to the power 8. So that will also giving us TLE. So how we can optimize it? So if you just look, so delta is starting with difference, and it goes from, so delta is going from difference to difference minus 1, then it is going a difference to difference minus 2, difference to difference minus 3, and so on. So what we can do is we can add another state that would be removing the for loop. So what we can do is we can compute it like this. Okay, so that is a maximum. We will be using the next positive index, we will be using the next negative index, and we are having a one more transition which is difference minus 1, and that would be reducing the for loop. Okay, so now we will be looking into the code, how we can compute the next positive index, next negative index, and how these things will be working. Okay, so now let's look into the code. So first we have taken the length of nums, the maximum number of nums. We have taken a dictionary which is seen. We have created a matrix for next negative index and next positive index. After that, we are computing the next negative index and next positive index. Okay, so we are trying from the n minus 1 to the 0 and computing the next negative and next positive integers. After that, for every I, we will be calling the solve function with the difference as m, which is the maximum number of nums. Okay, and for all of them we will try to get our answer. Okay, so first we will get the next negative index, then we will be getting the next positive index, and we will be checking that the next negative index is not equals to n, the next positive index is not equals to n, and then we are checking the difference is greater than 0 or not. Okay, because if it is not greater than 0, then we won't be going to difference minus 1. After that we are just computing it and returning the maximum, and here we can just return the max of answer. Okay, so that's it for this question. If you have any doubt in the question, please let me know in the comment section. I will try to resolve it. Thank you.